just within our Milky Way, billions with a B, of these rogue free-floating planets that we cannot see very well. In fact, we can't see very well at all. And where it goes to the next layer, these objects that are the size of Jupiter, which is, Dr. Agnew, can you help me with the scale of the size of Jupiter as compared to the Earth?
Wow. I wish I could. I think Jupiter is something like 1,000 times the mass of Earth. It is, every successful solar system has a planet like Jupiter. And what I mean by successful, you have to have a gravity vacuum, so to speak, inside every solar system that's not the sun. Every piece of space junk that comes through, like the comet Shoemaker, was vacuumed up by the gravitational field of Jupiter. If you don't have a Jupiter in your solar system, it means your other planets, especially the ones in the sweet spot like Earth, are going to get struck by objects coming through the solar system. That's why successful solar systems have a Jupiter-sized planet in them. Now, it's one thing to say that there are planets the size of Earth or gas giants like Neptune or Uranus, floating through space that may or may not have a real gravitational effect. But when you say that there are Jupiter-sized planets, these are planets that could literally rip a solar system apart.
Yes.
If they came through our neighborhood. And you're right. They don't show up on the radar screen. We don't have a detection system out there looking for planets. We just don't. We don't spend the money to put those kinds of satellites out there. We put satellites out there to make money, not to look out into space at what we call near-Earth objects.
That's quite right, and just so. And what I find now as the next turn of making this release that I'm reading from chilling, fascinating, 1,000 other adjectives that I don't have time to share just now, is from what we have discussed thus far. Again, they believe that there are as many of these Jupiter-sized free-floating rogue planets as there are planets, that conventional planets that we're aware of. That is very interesting. And just in case anyone, again, is curious about this, you can, not only from nasa.gov, dated 18th of May, but also the study led by Takahiro Sumi from Osaka University in Japan. This study appears in the May 19 of May, issue of the journal Nature. In the next paragraph, it explains that this survey that we're talking about is not sensitive to planets smaller than Jupiter and Saturn. It is not sensitive to planets smaller than Jupiter and Saturn, which means that we have as many of these free-floating objects the size of Jupiter as there are planets, conventional planets. But then in addition to that, we have some unknown number of these type of rogue planets that are smaller than Jupiter and Saturn. They are able to make no prediction, no estimate as to these numbers, because we completely lack the ability to see these objects, the ones that are smaller than Jupiter and Saturn. Dr. Agnew, could you take over for a moment there with that? Or some reaction?
Well, yeah, mathematically speaking, it's a good point of view to say that a solar system with 9 planets like ours has one Jupiter-sized planet. We could say for the average solar system that has 8 to 10 planets, one of them is going to be a Jupiter-sized planet. So it seems reasonable to say there's probably somewhere between 5 and 8 times as many smaller free-floating planets out there as there are Jupiter-sized planets out there. And you're exactly right. The sampling, and I'm going to use that word from a quantum physics point of view, because everything in space is just a macro version of what we see on the quantum level, with the exception that there's gravity thrown in, which we don't have on the quantum level. But we are talking about probabilities. We're talking about Heisenberg uncertainties, where it's difficult to predict the exact location and speed of everything in the universe. But we can take a sampling like that fingernail that you pointed up at space, Then we could say, okay, in this fingernail we have found this many planets, and the only reason we can see planets of that size is because we're looking so darn far away.
Yes.
You know, something smaller than that, we just don't have the resolution. A resolution, let me explain that to your listeners, is a little like the marks on your tape measure. As small as you can get those things, you really could not measure a grain of sand with a tape measure because there's just not enough resolution in the tape measure. In fact, most of us throw out the 30 seconds mark, and some of us throw the 16ths out, especially after you pass the age of 40. We use the 1/8 inch, we use the 1/4 inch, we use the 1/2 inch, but you can't go out there in space and measure a 2x4 with a micrometer and then mark it with a piece of chalk and cut it off with an axe and get something that's accurate. And that's the problem that we're faced with. We're sitting on a little planet way out here on the outer fringe of the Milky Way. We're looking into the Milky Way, parsecs away, trying to make a measurement on a grain of sand with a wooden third-grade ruler. And we just can't see anything smaller than a Jupiter-sized planet. But what we can see, we can make mathematical predictions about. And that's what we're talking about here.
And as much as I appreciate what you've just said, I also at the same time cannot help my thoughts to travel to your earlier analogy of a 747 and a fly. And it has me thinking that, you know, the pilot of that 747 really has no chance to see that fly's approach until it's already placing a gentle kiss on the windshield of the 747. And folks, with these free-floating planets, by the nature of their construction and by virtue of our insufficient technology, it's quite the same. It's quite similar in that we cannot see these until they are literally splattered on our windshield, so to speak. But just to recap quickly, don't forget, from NASA's own work, their own documentation, and also this study was presented in the May 19th issue of the journal Nature, in quotes, once again, direct quotes from the pieces. Not only are there many more free-floating Jupiter-mass planets that cannot be seen, not only does the team estimate there are twice as many of them as stars, not only do they estimate that they would be as common as planets, hence adding up to hundreds of billions of these, but thus far, those are all the Jupiter and larger size objects. And just a bit later in the piece, they go on to describe that the survey is not sensitive to the planets that would be smaller than Jupiter, and yet they are also thought to be more common than these free-floating Jupiters. Dr. Agnew, we'll take our break here just shortly, but your thoughts here before we do move into our short break.
Well, I particularly like your observation that we're not going to get much warning. You know, Elenin's traveling, as you said, 18,000 kilometers an hour, which is about 10 times the speed that Earth is traveling through space, which is about 1,900 kilometers an hour. And there's no rule that says that planets can't travel faster than it, especially if they've been blown out of their orbit by a supernova that occurred, you know, somewhere across the galaxy that we haven't even seen the light from yet.
Yes.
But those planets could be zooming along at 30, 40, 50,000 miles an hour or even faster than that. And they're going to show up eventually in our neighborhood, but they're going to show up right behind their light. And that means that when we see them, there's not going to be a whole lot of warning. Now, that being said, we only have one photograph of Elenin. Maybe there are no photographs available of one of these other planets that might be headed our way, and maybe no one is leaking it outside of the boardrooms of these agencies or departments. And I'm sure we're going to get into that in the second hour because there are some real indications that somebody knows something they're not telling us.
Quite right, and just so. Ladies and gentlemen, we're joined by the incomparable Dr. Brooks Agnew. I'm so privileged, sir, to have you join us. So you have my sincerest thanks. We're going to take a short pause in the program here, give ourselves a chance to splash a little cool water on our faces because we need to be really alert and ready to learn in the second hour as we continue to quote from NASA.gov documents, and press releases, as well as space.com information pieces that are quite normally or customarily produced in handshake fashion with NASA's informational arm. And so, continuing right from the words of the source themselves, Dr. Agnew and I will go deeper and further down the rabbit hole in the second hour. And it's just our sincerest thanks that you, the listener, are joining us for this interesting little ride through the solar system as well. Let's cue the music. We'll take a break. About 4 minutes from now, we'll be rejoined by Dr. Brooks Agnew, and we've got a lot of really wild stuff to share with you. Remember how I led the show, folks? What if you suddenly learned that the world is not what you think it is, in the words of my friend and guest from our first program, Mr. Jordan Maxwell? What if the world is not at all what you think it is? Well, your next calendar week would change significantly. Work would have a different sense of prioritization. Spending time with family would have a renewed sense of urgency and priority in your life. Your humble host, and neither Dr. Agnew either, mean to imply that this is the sort of end result that we're talking about. But, it's important to ask the question, what if? And that's what we'll do when we come back in just a few moments.
He is the creator and sustainer of all the worlds, whether those worlds are known or unknown to mankind. He is the creator and sustainer of all the worlds, of all the worlds, worlds, all the worlds. He is the creator and sustainer of all the worlds, whether those worlds are known or unknown to mankind.